welcome to another WJEC A level physics question. This is question 3 from June 2017's PH5 paper on nuclear energy, which is currently in Unit 3. We've got to calculate the binding energy per nucleon of carbon-14. The way that we do this is very straightforward. We add together the masses of the particles that make up the nucleus first of all. So we're going to add together 6 of the protons and 8, because remember the mass number of 14, take away the atomic number of 6 gives you the number of neutrons. So 8 lots of 1.008665, and then we're going to subtract from that the mass of the right hand side, the 13.999950. You could do that all in one step, but what I like to show here is that the mass of the constituent particles is actually 14.112976 U, and again we're going to take the 13.99995 away, and that will give us a mass difference of 0.113 U's, 113026 to be precise, and then the binding energy will be that times 931, 1 U is 931 MeVs, so that will give us about 105 MeVs. And finally the binding energy per nucleon will be that divided by 14, because again there are 14 nucleons here, and that will give us 7.52. Next, that carbon-14 decays by beta emission to nitrogen-14, a beta particle, an electron in other words, and an electron antineutrino. We're going to calculate the energy released in this reaction. So all we're going to do again is find the difference in mass between the left-hand side and the right-hand side. So it's 13.999950 minus the total here of 13.999234. for the nitrogen nucleus and 0.000549 U's for the beta particle. That is 13.99973. The difference between them is 0.000167 U's, and then the energy released is that times 931 MeVs, which is 0.155 MeVs. So fairly simple, very common type calculation. Find the difference between the mass on the left and the right and turn it into energy. For the last part of the question, we're going to consider the case where the antineutrino has 0 momentum. Well, its mass is negligible, so that's fair. And the carbon-14 nucleus is initially at rest. And we're going to explain briefly, using conservation of momentum, which particle, the nitrogen nucleus or the beta particle, receives most of that energy that was released in the reaction. Well, the first thing to note is if the initial carbon nucleus was stationary, the total initial momentum was 0, and therefore the total final momentum must be 0. And that means that the nitrogen nucleus and the beta particle have equal and opposite momenta. Now momentum is mass times velocity, and because the nitrogen has a much bigger mass than the beta particle therefore must be moving much faster than the nitrogen nucleus. Now, the energy that's released in this reaction basically is the kinetic energy of those two particles. And kinetic energy is half mv squared. Kinetic energy depends on v squared. It also obviously depends on mass, but the important point here is that kinetic energy depends on v squared, not just v. So v is the most important factor. So the beta particle with a higher V will have much more energy than the nitrogen nucleus. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.